As we've pointed out in previous programs, classifying hazardous chemicals is a convenient way to study their effects and helps us to remember how to protect ourselves from those effects. But many chemicals present multiple hazards. This is especially true of today's subject: irritants, corrosives, and sensitizers. Take sulfuric acid, for example. It's certainly a corrosive chemical. We'll learn what that means later. But it's also toxic, a strong oxidizing agent, and violently reactive with water. Sulfuric acid and many of the chemicals we're going to talk about today can be life-threatening. So it's especially important to follow safe procedures, be alert at all times, and not take chances. To help recognize these chemicals in your workplace, let's go to the HAZCOM Report's authority on definitions, Professor Sharp.
Thank you, Barry. I'm here today to clear up some of the terms you'll see on labels and material safety data sheets. Our textbook is going to be this HAZCOM glossary. Now, first of all, let's see what OSHA defines as an irritant. An irritant is a substance which, by contact over a sufficient period of time, will cause inflammation of the eyes, skin, or throat and lungs. The irritation may occur after only one exposure, or it may take place after multiple contacts with the chemical. Here are some commonly known irritants that you may encounter at work, or for that matter, even at home. Now, of course, some of them have a more severe effect than others, and we'll go into what effects those are a little later on in this program. Now, we'll look at the definition of a corrosive. Our glossary says that a corrosive is a chemical that causes visible destruction of living tissue at the point of contact. Corrosives can also attack other materials, such as metals, so care must be taken in how they are stored and transported. Now, most acids are corrosive, particularly in stronger concentrations. These common acids are listed here in order of their corrosive hazard, with nitric acid as the most dangerous. Weak acetic acid is known as vinegar, but in concentrated form it's called glacial acetic acid and will severely burn your skin and eyes. Hydrogen sulfide is an acid that is also extremely toxic. Bases, such as these shown here, are also corrosive. Now, some of them are highly toxic, such as aniline, for instance. Aniline can even be absorbed through the skin. Ammonium hydroxide is only mildly corrosive. As a matter of fact, in a weak form, it's a common household product, but it can be highly irritating to the eyes. The third class of chemicals we're talking about today are called sensitizers. Now, our glossary says that sensitizers are substances that usually don't cause any trouble on the first exposure, but they may eventually produce an allergic reaction such as a skin rash or respiratory problems. Here are some examples of known sensitizers. In other words, chemicals that have produced allergic reactions in test animals and accidentally in human beings. You know, Mother Nature provides us with a very good example of a sensitizer, poison ivy. Many people don't react to poison ivy the first time, but on re-exposure, they immediately break out in a rash. Well, that's all for today. Now that you've seen some examples of irritants, corrosives, and sensitizers, I'll return you to Barry.
Thanks for that lesson, Professor. As with any hazardous chemical, knowing the hazard is your first line of defense, and your source for knowledge is reading labels and material safety data sheets. Labels such as those specified by the Department of Transportation and more detailed labels affixed by the manufacturer of the chemical will tell you basic information about the relative hazards of the product. For more detailed information, always refer to the MSDS and written procedures published by your own company. For example, here's an MSDS for hydrochloric acid, which is a highly corrosive chemical. Notice the threshold limit value, or TLV, is only 5 parts per million. Any exposure above this concentration is considered unacceptable. The health hazard section of the MSDS lists the specific effects of overexposure for skin contact, inhalation, and ingestion. In case of emergency or first aid, we're told to flush the eyes and skin with flowing water for 15 minutes and remove to fresh air if fumes were inhaled. Note that we are not to induce vomiting if any of the acid were swallowed, but give large quantities of water or milk. And of course, immediately call a physician. If this chemical were an irritant or sensitizer, it would be listed in this section. In the spill or leak section of the MSDS, we learn to contain and neutralize the chemical with soda ash or lime and dilute with water. The personal protection equipment called for is an acid gas or air supply respirator, rubber gloves, boots, apron, and chemical goggles or face shield. It doesn't pay to take chances with chemicals that can harm you even in small amounts. To illustrate what can happen if we don't pay attention to all the details, we have an on-screen interview lined up with a worker who had a painful reminder. We're talking to Dale Bowden, an operator at a plant where nitric acid is used in processing. Welcome to the HAZCOM report, Dale. What's the story behind that bandage?
An embarrassing one, I'm afraid, Barry. You see, one of my jobs is to periodically test the stored nitric acid we use to make sure it meets specs. And, well, I was wearing my acid suit and my face shield. Always do when I tap into that tank. The only thing was, I forgot to bring along the Viton gloves. They're resistant to nitric acid. But there on the table was a pair of work gloves somebody had left behind. So I figured, what the heck, they'll do. I never spilled a drop doing this before. So I just went ahead to get the sample. And then, well, I guess I got to thinking about my vacation next week. The next thing I knew, that acid was pouring on my glove. I mean, I couldn't believe it. And before I could react, it burned right through those gloves and into me. Yeah, it did smart a bit. But we've had training in first aid for burns. So I knew to get those contaminated gloves off and get to the shower. I washed my arm and hand for about 15 minutes. It really gave me a scare. After that, I advised my foreman and went to the infirmary for further treatment. And my boss reported the spill to Sam here so they could clean it up.
We've been joined by the plant safety engineer, Sam Price. Sam, how could this accident have been avoided?
Well, Barry, the first thing we try to impress upon all our employees who have to deal with hazardous chemicals is to stay alert and don't take things for granted, like gloves, for instance. The protective equipment we recommend depends on the properties and concentration of the chemical and on the potential harm that could be caused by exposure. For working with strong acids, as an example, we may call for an acid suit or a rubber apron for weaker and less dangerous solutions. A face shield protects the eyes from splashes. To prevent vapors from irritating the eyes, we use these chemical goggles, which should fit tightly enough to seal properly. A respirator may be required if airborne substances could exceed the TLV for the chemical. Protective gloves made from the correct material to resist the specific chemical involved, and boots made from the same material to protect the feet from contact with the chemical. And since all jobs are different, we've come up with this chart that outlines what equipment is required when.
It's obvious that using the proper type of protective equipment is especially important in handling corrosives, irritants, and sensitizers. Thank you, Dale and Sam, for sharing your experience with our viewers. A serious injury was prevented in this case, but these types of chemicals don't always give you a second chance. To find out more about how they can hurt you, we have a taped report from Dr. Rosemary Brock, a specialist in occupational medicine.
Today we're going to see how irritants, corrosives, and sensitizers affect the human body and why it's so important to protect ourselves from them. First, let's take a look at irritants, which can cause inflammation of the eyes, skin, and respiratory passages. In the workplace, the most common way you're exposed to irritants is by breathing their vapors. Irritants which are highly water-soluble, such as the example shown here, are trapped in the upper respiratory system where they can cause burning or choking. Other chemical irritants such as these are less soluble and can get into the lungs where their effects can be more severe. A third group of irritants are essentially insoluble and can penetrate to the far reaches of the respiratory system. These are especially dangerous. In fact, phosgene was used as a chemical weapon in World War I. Corrosive chemicals destroy living tissue. The extent of the damage depends on the concentration of the chemical and the time of exposure or contact time. Highly concentrated corrosives can cause severe damage in a short period of time. But if the chemical is immediately washed off with water, the damage will usually be minimal. Acids like sulfuric or bases like sodium hydroxide, commonly known as caustic soda, can cause severe chemical burns to any part of the body they come in contact with. If inhaled, severe injury can result, such as perforation of tissue, internal hemorrhage, or obstruction of air passages. Secondary complications include shock or the risk of infection. Chemicals that we call sensitizers are unusual in that the first time you're exposed to them, they normally don't cause any problem. However, upon prolonged or repeated exposure, they can cause an allergic reaction in the skin, eyes, or internal organs. The responses to sensitizers can include skin lesions or rashes, dermatitis, itching, and conjunctivitis of the eye. However, sensitizers have been known to cause fatal shock in humans. Avoiding the adverse effects of these kinds of chemicals is generally a matter of eliminating or limiting the possibility of exposure by understanding the hazard, following proper handling and storage procedures, and using the recommended protective equipment.
I'll add one more thought to what Dr. Brock said. Don't take chances with these chemicals, and don't assume someone else is looking out for your personal safety. Now we have an on-screen interview with a maintenance worker to illustrate that point. Welcome to the HAZCOM report, gentlemen. I understand you work in a fertilizer plant that uses ammonia and that you've just had an accident with it. Tell us what happened.
Well, it wasn't all my fault, I can tell you. You see, my job is to overhaul valves in our ammonia lines. And I'm careful, too. Well, usually. Anyway, it all started when they gave me this work order to repack a valve.
I can't believe they want this valve repacked now. 30 minutes before quitting time. At least I won't have to shut down and drain the line. Seems like somebody already did that on the last shift. Why in the heck didn't they just go ahead and finish the job? Okay, if I hurry, I can pack this baby and get out of here on time. This line's dead, so I don't have to waste time getting into all my safety gear. What in the... the line's under pressure, I can't breathe, my eyes! I can't breathe,
So there was ammonia in that line after all. You look okay now, though.
Yeah, I'm all right. Luckily, my supervisor came along and gave me some oxygen until I could breathe. Then he took me to the eye wash station to wash out my eyes.
What about it, Doctor? Was that the proper emergency treatment?
Yes, it was, Barry. Ammonia gas is an irritant that can cause burning of the eyes, and if inhaled, attacks the upper respiratory tract. That's why I had trouble breathing. Depending on the type of chemical exposure, there are several first aid techniques to follow. Usually the first thing to do is to remove the victim from the site of the exposure. If he's not breathing, immediately administer artificial respiration until breathing is restored. If breathing is difficult, give oxygen. Any contaminated clothing should be removed to stop further contact with the skin. Any parts of the body exposed to the chemical should be flushed with running water for at least 15 minutes. Then as soon as possible, get the victim to a physician.
Sounds like quick action in this case prevented serious injury. Thank you both for joining us on today's HAZCOM report. We've seen why it isn't a good idea to depend on someone else for your safety. Always double check. And personal safety equipment doesn't do you any good hanging in a locker. But a major concern in protecting employees from irritants, corrosives, and sensitizers is to prevent or limit exposure through proper storage and handling. For more on that, let's go to a taped report from Bill Curry, a safety engineer.
Irritants, corrosives, and sensitizers share one characteristic. They can affect you adversely, even in small amounts or doses. So it's particularly important to store and handle them in a way that prevents contact. Since corrosives such as acids and bases represent the most difficult storage and handling challenges, let's look at some of the ways they are handled to prevent leaks, spills, and exposure. Because they are so reactive, corrosives are transported and stored in special containers that are lined and coated with a material that will inhibit any reaction. In storage, it's important to keep acids and bases separate from one another and from any other chemicals with which they'll react. Adequate ventilation must also be provided, as well as water systems for diluting any spills. In transferring from one site to another, modern practice calls for closed piping systems that eliminate human exposure. When they must be handled by people, special glass reagent bottles like this one are used. This Teflon-lined container is designed for storing and handling small amounts of glacial acetic acid, such as that used in the electronics industry. Teflon is one material that is highly resistant to corrosiveness. When you're handling any of these types of chemicals, exercise extreme caution not to allow spills or leaks. Don't let the chemical contact your skin or eyes, and don't breathe the vapor. If a spill occurs, report it immediately. Then don your personal protective equipment and follow the instructions in the MSDS for cleanup and disposal.
Health hazards cannot harm you if you take the responsibility to protect yourself. Learn what the dangers are and how to recognize dangerous situations. Read labels and the MSDS. Wear the right protective equipment. And finally, use your common sense. And with those thoughts in mind, it's time to wrap up this edition of the HazCom Report. In today's report, we looked at the characteristics of irritants, corrosives, and sensitizers. We illustrated the importance of using the proper protective equipment and what types of equipment are available. We reviewed a typical MSDS and learned where to find the information you need to keep safe. We saw what kind of effect irritants, corrosives, and sensitizers can have on your body. And we looked at some of the methods used to safely store and handle these hazardous chemicals. In future editions of the HazCom Report, we'll explore other chemical hazards and how you can protect yourself from them. But for now, I'm Barry Lerner, and this has been the 9th in our series of HazCom Reports. Thank you for watching.